I think we have a bit of a PR problem when it comes to computers.
Oh, yeah. How so?
We have this Hollywood version of AI, right? Where you turn on the machine, the screen glows red, and suddenly it knows everything.
Right.
It can fly a spaceship, diagnose a rare disease, and beat you at chess, all within like 5 seconds of booting up.
It creates a very romantic, but a very misleading picture of technology.
Yeah.
We see the magic trick, but we completely ignore the years of practice that went into it.
Exactly. We think of them as these super geniuses just born ready to go. But the reality we're diving into today is so much more, well, humble.
And more human, really.
And honestly, it's a lot more human. The fundamental premise of the research we have today is that computers are not born smart. They're blank slates. They are clueless until we intervene.
That is the crucial distinction. We aren't just, programming them in the old sense. We're sort of raising them. Just like a child, a computer needs guidance, it needs structure, and most importantly, it needs examples.
It doesn't just know the answer.
No, it has to be taught the answer first.
And that brings us to the topic of this deep dive. We're unpacking supervised learning. And I have to say, the material we're working with today, this AI for Everyone module, it's really refreshing.
It is.
It completely strips away the Silicon Valley buzzwords. There's no talk of neural networks or black boxes yet. Instead, it grounds everything in very relatable, real-world African contexts.
Which is how it should be explained. Because at its core, this isn't about some magic code. It's about a very, very specific way of teaching a machine to make decisions.
So let's set the mission for today. We want to demystify how AI actually learns. We want to move past the hype and really get into the mechanics. Because once you grasp what the researchers call labeled examples, you basically hold the key to understanding, 90% of the AI news you hear every day?
It really is the foundational block. If you understand supervised learning, you understand the engine behind the car.
Okay, so let's get into it. Supervised learning. If I'm just hearing that term, it sounds a bit like a detention hall. A teacher standing over you with a ruler. What are we actually talking about here?
It's not that far off. But think of it less like detention and more like a guided study session. Supervised learning is simply the process of training a computer using labeled examples.
Labeled examples. That's the jargon. Let's break that down. What does a labeled example look like in the wild?
Think of it as a two-step mechanism. First, you have the input. That's the data, the raw situation. But, and this is the absolute key, we also provide the label.
The label.
The label is the correct answer.
So we aren't asking the computer to figure it out alone?
No,
No.
not yet. We're giving it the cheat sheet. We show it the question, and we immediately show it the answer.
Okay, so if I'm the computer, you're showing me a picture of a cat, and you're explicitly telling me this is a cat.
Exactly. And then I show you a dog, and I say, this is a dog. I do that thousands, maybe millions of times. That is a supervision. I am supervising your learning by providing the ground truth.
But wait, if I just give it the answers, isn't it just memorizing? Like if I memorize the answers to a test, I haven't actually learned the subject. I just learned the test. How does that help the computer handle new stuff?
That is a pivotal moment. That is where the learning actually happens. The computer isn't just storing the images. It's studying the patterns that connect the image to the label.
Ah, okay.
It's looking at the cat and asking, okay, every time I see this pointy ear shape and these whiskers, the label is cat. But when I see a long snout and floppy ears, the label is dog.
So it's figuring out the rules on its own.
Precisely. We provide the data and the answers. The machine discovers the relationship between them. Once it locks onto those patterns, it can look at a picture of a cat it has never seen before, a new cat, and predict the label correctly.
It's pattern recognition, not just storage.
It is exactly pattern recognition. And the source material uses an analogy here that I think is just brilliant. It resonates with anyone who went to school in West Africa, or honestly, anyone who has ever faced a standardized test. It talks about the WAEC student.
Oh, the WAEC exams, the West African Examinations Council. I felt my heart rate spike just hearing that acronym. The stress is real.
It is a universal experience, but think about how you prepared for those exams. You didn't just walk in blind hoping for the best.
No way. You get the past questions book, that big, thick book that has every question from the last 10 years.
Exactly. And usually, the back of the book has the answer key.
Right. So in this analogy, the past questions are our input data.
And the answer key? provides the labels.
So picture this student. They're sitting at their desk late at night, sweating a little bit. They read a question from 2018. Then they flip to the back and check the answer. They read a question from 2019, check the answer.
Now, here's the question for you. Is the student trying to memorize that specific question from 2018?
No, because that specific question won't be on the exam next week. That would be, well, useless.
Exactly. If the student just memorizes, they fail. The student is doing exactly what the AI does. They are looking for the pattern. They're realizing, oh, every time the question asks about force and mass, I need to use Newton's second law. They're learning the logic behind the questions.
So when they walk into the exam hall on Monday morning and they open that paper, they see a brand new question, new numbers, different phrasing, but they don't panic.
They don't panic because they recognize the pattern. They apply the logic they learned from the labeled examples of the past to the unlabeled data of the present.
That's actually a perfect description. It takes the magic right out of it. The AI is just a really, really diligent student who has studied millions of past questions.
A student who never sleeps and never, ever forgets a pattern. That is the power of it.
Okay, so we've got the student in the classroom, but let's take this out into the real world. Because passing an exam is one thing, but the material highlights some applications that are literally life or death. The first big one is healthcare.
Right.
Specifically, diagnosing malaria.
This is a massive issue. Malaria is still a leading killer in many parts of the world. Early and accurate diagnosis is everything.
So how do we turn a computer into a doctor? How do we use this labeled example concept here?
Well, think about what a hospital has. They have filing cabinets or, servers stuffed with patient history. Thousands and thousands of patients.
So that's our past questions book.
Right. And for each patient, we have the inputs: age, specific symptoms, maybe a fever temperature, and crucially, the blood test results.
And the label?
The label is the final diagnosis the human doctor made at the time: malaria or not malaria.
So we feed all of that into the system. We say, here's patient A, high fever, chills, blood smear looks like this. The doctor said malaria. Then here's patient B, headache, normal blood. Doctor said not malaria.
And the AI starts to crunch that data. It looks at the correlation between the blood smear patterns and the label malaria. It learns that specific combination of symptoms that usually leads to a positive diagnosis.
And why is this better than a human? I mean, doctors are pretty good at this.
Doctors are excellent, but doctors get tired. Doctors have bad days. Doctors can be overwhelmed when there are 500 people in the waiting room. The AI can look at a new patient's blood test and, based on the pattern it learned from 100,000 previous cases, predict the diagnosis instantly.
It's like having a doctor who has created every single patient in the hospital's history and remembers every single detail.
Exactly. It doesn't replace the doctor, but it gives them an incredibly powerful tool. It flags the pattern immediately.
That is incredible. But it's not just health. The discussion moves to something that affects, well, everyone's pocket: financial security, specifically mobile money.
This is huge. In many African economies, mobile money isn't just an app. It's the entire banking infrastructure. Millions of transactions happen every single hour. And where there's money, there are thieves. Fraud is a massive problem. But how do you catch a fraudster using supervised learning? Because fraud changes all the time, doesn't it?
It does, but fraudsters are creatures of habit. They leave digital fingerprints.
So what's the label here?
The mobile money companies have historical data. They know which transactions were legitimate, and they know which ones turned out to be scams. So the label is simply fraud or not fraud.
Okay, so the AI studies the fraud pile. What is it looking for?
It's looking for the subtle patterns that a human might miss. Maybe it notices that 99% of fraud cases start with 3 tiny transactions of $1, followed by a massive transfer at 3 a.m.
A human reviewing a spreadsheet might not even notice the $1 transactions, they just see the big one.
Or they might see it, but only a week later during an audit. That's too late. The money is gone. The supervised learning model, once it's trained, just sits there watching the live stream of transactions. The moment it sees that pattern, the fingerprint of fraud, it flags it. It predicts, this looks like fraud, before the money even leaves the account.
Speed and scale. That is what the AI brings to the table. It can check 1 million transactions a second against the patterns it learned. No human team can do that.
So we've got diagnosing sickness and we've got catching thieves. But there's one more example in the notes that I think is really interesting because it shifts how we think about the answer. We're going to the farm.
Yes, the agriculture example. This is vital for food security.
So imagine the farmer. What are their inputs? What is the data they're dealing with?
The environment. The notes list things like rainfall, soil quality, fertilizer usage, temperature. These are all the variables.
And the label.
The harvest, specifically the crop yield. How many tons of maize or cassava did we actually get at the end of the season?
So if we have 10 years of data, the AI can look at the weather patterns and the soil types and see how they connected to the final yield.
Exactly. It learns the relationship.
Right.
When rainfall is low, but we use this specific fertilizer on this soil type, the yield is high. When we use that fertilizer on that soil type, the yield just crashes.
And the goal here isn't just to categorize, right? It's to predict the future.
It's about foresight. If a farmer can input the forecasted rainfall and their soil data before they even plant, the AI can predict the yield. It can say, if you do this, you will likely get 10 tons. If you change the fertilizer, you might get 15 tons.
That's a game changer. That's the difference between barely surviving and making a profit. But you touched on something there, the difference between the answer being malaria versus 15 tons. Those feel like different kinds of answers.
You have spotted the two main families of supervised learning. This is a little technical, but it's actually really helpful to know. The distinction is between classification and regression.
Okay, let's unpack that. I hear regression and I get high school math flashbacks. Help me out.
It's actually pretty intuitive. Just think about the answer you want. In the malaria example or the fraud example, what kind of answer are we looking for?
It's a yes or no, sick or not sick, fraud or legit.
Right. You're sorting things into buckets. You are classifying them. That is classification. The source also mentions spam versus not spam for emails. It's a category.
Okay, so if the answer is a word or a label, it's classification.
Generally, yes. Now look at the farmer. Is the answer high yield or low yield?
Well, it could be,
Yeah.
but usually you want to know the number. You want to know how many tons.
Exactly. You want a quantity. You want a specific number on a continuous scale. It could be 10.5 tons. It could be 500 tons. That is regression.
So regression is when the answer is a number.
Yes. The notes mention house prices is another great example. You don't ask, is this a house? You ask, what is the price? The answer is a value.
That's a really helpful mental shortcut. Classification is sorting mail into slots. Regression is weighing the package on a scale.
That is a perfect analogy.
So we've covered the what training with labeled examples. We've covered the how finding patterns like a student. We've covered the types, classification, and regression. But I want to zoom out for the last part of this deep dive. The material explicitly discusses why it matters, and it goes beyond just cool tech.
It does. It frames it around development. Why does this matter for a region? Why does it matter for Africa or really anywhere that's developing its infrastructure?
Because it's not just about gadgets, it's about solving fundamental problems.
We talked about healthcare better diagnosis means fewer deaths. We talked about agriculture better yield prediction means food security. We talked about finance fraud protection creates trust in the banking system.
But the list goes on. The material mentions education and climate.
Think about education. If we can use supervised learning to look at student performance data, maybe we can identify students who are at risk of dropping out before they drop out. We can spot the pattern of a struggling student early on.
And climate.
Predicting rainfall patterns, predicting drought. This connects right back to the farming example. It allows us to prepare.
The big takeaway for me here is that supervised learning is basically an engine for turning hindsight into foresight.
That's a beautiful way of putting it.
It takes all the data sitting in dusty filing cabinets, the hindsight, and turns it into a prediction tool, the foresight.
And that is why the label is so important. We can only predict the future if we have properly understood the past. The data is the experience. We are giving the machine experience.
So if we strip it all down, the formula is simple. Inputs plus labels equals learning.
Simple formula, profound impact.
Before we wrap up, though, I have one thought nagging at me. It goes back to our WAEC student.
The students sweating in the exam hall.
Yeah. We said the student succeeds because they recognize patterns from the past questions. They pass because the exam questions follow the same logic as the practice book.
Correct.
But what if they don't? What if the world changes?
That is the fundamental limitation of supervised learning.
If the AI is trained on data from 2010 to 2020, it knows the patterns of that decade perfectly. But if something happens in 2025 that has never happened before, a completely new type of economic crisis, or a disease with symptoms we've never seen, what does the AI do?
It fails. Or worse, it tries to force the new situation into an old pattern. It tries to answer a physics question using history logic.
That's the unseen question.
Exactly. If the past questions don't match the reality of the future, the student fails. The AI is only as good as the history it has studied. It cannot imagine a future that looks different from the past.
Which means, as powerful as this tool is, we can't just turn it on and go to sleep. We still need humans to check if the world has changed.
We do. The supervision never really ends.
That is something to chew on. We're building these incredible prediction machines, but they're looking in the rearview mirror to drive the car.
And as long as the road is straight, that works. But if there's a sharp turn ahead,
You better have your hands on the wheel. This has been a fascinating look into the mechanics of how machines learn. I'll never look at a CAPTCHA asking me to identify traffic lights the same way again. I'm just providing labeled examples, aren't I?
you are. You are the supervisor.
Well, there you go. We are all teaching the machines. Thank you for helping us unpack this today.
My pleasure.
And thank you to everyone listening. Keep asking questions, keep looking for the patterns, and we'll catch you on the next deep dive.